G'day guys, we've got a couple of maths questions here today, and before we start I'd just like to say this is my 300th video that I'm posting on YouTube, and yeah, thanks for watching. If this is your first time to my channel, I am great, I do appreciate it. If you guys are repeat, offenders, I'm really humbled. We've got 34,000 and a bit views, which I know is nothing in YouTube sense, but 34,000 views on maths videos is, I think something. So thanks a lot. I really do appreciate it. So today I've got something a little bit different. What I've done is I've got a question that one of the students of mine has just asked, and I've literally just slapped it up here, and I'm going to try and do it on the fly for you guys live. So let's see how we go. So we go solve each of the following equations. We've got log x4 equals 2. Okay, well, to start with this one, we have to know like how logs work, and in this case, we've got x to the power of 2 equals 4. So that's how we can rewrite this one. We've got x to the power of 2 equals 4. Now, in this case, x has to be greater than 0, So basically, because normally we could go, well, x is going to have to be plus or minus 2 because of the squared, but x is going to have to be greater than 0. So in this case, we're just going to have x is equal to 2. Great. On to the next one. E to the 2x equals 5. Now, we've got this, our variable which we're trying to solve for is in the power. So when a variable is in the power, you need to that should be a red flag for doing logarithms. And because we have a base of e, I'm going to use natural logs. So what we do is we take the natural logarithm of both sides. So we have ln of e to the 2x is equal to ln of 5. Now we can use the index law, ln of a to the b is equal to b times ln of a. And the way we use that here is we can bring the 2x down the front and say, well, this is going to be 2x times ln of e is equal to ln of 5. Now, ln of e, because the natural logarithm is just log to the base e, any logarithm to the logarithm of whatever's in the base, like if I have log to the base 10 of 10, these always equal 1. So log to the base e of e is going to equal 1 and disappear. So what we're going to do next is we're just going to have 2x is equal to ln 5. And finally, we can just divide both sides by 2. And we have x is equal to ln of 5 divided by 2. Cool. Finally, let's get on to this last question. All right, what have we got? So we've got if log a plus log a squared plus log a cubed is plus everything up to log a to the 50 is equal to k log a, determine k. Okay, well, we're going to use this index law to start with. And from that, what we're going to do is we're going to say, well, log a plus log a squared plus log a cubed plus dot 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 plus log a 50 is equal to log of a plus 2 log of a plus 3 log of a plus dot 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 plus 50 log of a. Great, just fit it in there at the end. So what we have here is we could then, if you want to, we could factorize this by log of a. So we could have and we've got 1 plus 2 plus 3 plus dot 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 plus 50 inside the brackets. Now here we have an arithmetic sequence. So what we're going to have is we need to sum an arithmetic sequence where we know the last term. So the sum of n terms, if we know the last term, is equal to n on 2 times a to the 1 plus a to the n, which in this case is equal to 50 on 2 times a1, which is 1, plus 50. Okay, so we have this is equal to 25 times 51. Now this is in the non-calculator section of an exam. So we know that 25 times 50 is 1,250, and 25 times 1 is 25. So that's going to equal 1,275 is equal to K. Great. So we got through those 7 marks, I think, relatively quickly. You know, hopefully a bit less than 7 minutes. This is an actual exam. I think it's taken from one of the practice exams in the current curriculum that we study here in Western Australia. I think just to master these questions, you need to have a basic understanding of logarithms, logarithmic laws and how they operate, but also they've given you like a bit of a curveball question with the logarithms here where it's involved an arithmetic sequence, which is, you know, I think quite an interesting one. You know, under exam conditions, I don't know how many, you know, teenagers would get that question, but, you know, you win some, you lose some. I would suggest that if you're going to do questions like this, try and do them under exam conditions. Try and make yourself sweat a little bit and see, you know, how well you perform under the pressure, but also if you're able to think clearly under pressure and take a deep breath, step back and go, oh, okay, this is how it works. Because, you know, like we try stuff at home and we're under, you know, no illusions that, you know, we sometimes take 15, 20 minutes to do a question that we should be doing in 5, 10 minutes max in an exam. So we need to be like getting those quicker. And if you can't do the question or you don't know exactly how to do it, know how to write a few things down so you can at least get a few part marks. But, you know, guys, that's just my ramble for the day. Again, this is my 300 video. Thanks for watching. You know, bit of a milestone. If you haven't already, definitely subscribe to my channel. I put out new videos all the time. And until next time, guys, enjoy your maths.